Have you ever looked up at the sun and wondered what its story is? Not just how it shines today, but how it will all end. It's a question that takes us billions of years into the future, on a journey to the very end of our solar system's life. Don't worry, we've got plenty of time, but the story of the sun's death is one of the most epic tales the universe has to tell. Right now, our sun is in its prime. It's about 4.6 billion years old, a middle-aged star, comfortably fusing hydrogen into helium in its core. This process, called nuclear fusion, is what releases the tremendous amount of energy that warms our planet and makes life possible. The sun is incredibly stable, like a perfectly balanced cosmic engine. For every bit of gravity trying to crush it, there's an equal amount of outward pressure from fusion pushing back. This delicate balance is what has kept our solar system a calm and habitable place for billions of years. But this can't last forever. The fuel in the sun's core is finite. So, what's the first sign that things are changing? It all starts deep within the sun's core. In about 5 billion years, the sun will have burned through most of the hydrogen in its very center. Think of it like a car starting to sputter as the gas tank runs low. Without the hydrogen fuel, the fusion in the core will slow down. Gravity, which never takes a break, will start to win the cosmic tug-of-war. The core will begin to contract and heat up under its own immense weight. This is where things get really interesting. As the core shrinks and gets hotter, a strange thing happens. The heat will radiate outwards, causing the layer of hydrogen just outside the core to become hot enough to start its own fusion. It's like a backup generator kicking in. This new shell of hydrogen fusion will produce even more energy than the core ever did. All this extra energy will push the sun's outer layers outward, causing it to expand dramatically. Our stable, friendly sun will begin its transformation into a red giant. As it swells, the sun will get bigger and bigger and bigger. Its surface will cool down, which is why it will glow with a reddish-orange hue, hence the name red giant. But don't let the cooler surface fool you. The total amount of energy it's blasting out will be immense. From Earth, the sun would look terrifying. It would fill a huge portion of our sky. So what does this mean for the planets? Well, it's not good news. Mercury, the closest planet, will be the first to go. It will be completely engulfed and vaporized by the expanding sun. Venus, the next in line, will meet the same fiery fate. And what about Earth? For a long time, scientists debated whether Earth would be swallowed or just barely escape. The latest models suggest that, yes, our planet will almost certainly be consumed by the red giant sun. Even before it's swallowed, Earth will become completely uninhabitable. As the sun expands, its intense heat will boil away our oceans, strip away our atmosphere, and bake the surface into a scorched, lifeless rock. The habitable zone, the region around a star where liquid water can exist, will shift outwards. Maybe, just for a little while, the moons of Jupiter and Saturn, like Europa and Titan, could experience a brief, temporary spring as the sun's warmth reaches them. But it won't last. The red giant phase will last for about 1 billion years. During this time, the sun will continue its internal battle. The helium core, which was just sitting there getting compressed, will eventually become so hot and dense that a new kind of fusion will ignite. It's called the helium flash. In a sudden, violent burst, the sun will start fusing helium into heavier elements like carbon and oxygen. This new energy source will temporarily push back against gravity, causing the sun to shrink a bit and become more stable, but it's only a temporary reprieve. Helium is a much less efficient fuel than hydrogen, and the sun will burn through its helium supply in only about 100 million years. That's a blink of an eye in cosmic terms. Once the helium is gone from the core, the sun's fate is sealed. It just doesn't have enough mass to ignite the carbon and oxygen into even heavier elements. For more massive stars, the story continues with more fusion stages, but for a star like our sun, this is the end of the line for fusion. With no more fuel to burn, the nuclear furnace will shut down for good. Gravity will finally claim its ultimate victory. The core will collapse one last time, shrinking down into an incredibly dense object about the size of Earth. This remnant is called a white dwarf. It's one of the strangest objects in the universe. A single teaspoon of a white dwarf would weigh as much as an elephant on Earth. It's the smoldering, super-dense corpse of a once mighty star. But what about the sun's outer layers? As the core collapses, the outer layers, which had expanded so far into space, will become unstable. The dying sun will pulsate, rhythmically expanding and contracting, and with each pulse, it will shed its outer atmosphere into space. These puffs of gas will drift outwards, forming a beautiful, intricate cosmic cloud. This expanding cloud of gas and dust, illuminated by the intense ultraviolet light from the hot central white dwarf, is called a planetary nebula. The name is a bit misleading. It has nothing to do with planets. Early astronomers with their less powerful telescopes thought these glowing rings looked like gas giant planets, and the name just stuck. These nebulae are some of the most stunning objects we can see in the night sky, like the Ring Nebula or the Helix Nebula. They are the ghosts of dead stars, cosmic butterflies emerging from their stellar cocoons. Our solar system will become one of these. The planetary nebula won't last forever. Over tens of thousands of years, the beautiful gas cloud will expand and dissipate, blending into the vastness of interstellar space. The elements that were forged inside the sun, the carbon, the oxygen, will be recycled, becoming the raw materials for new stars, new planets, and maybe, just maybe, new life somewhere else in the galaxy. It's a beautiful thought, isn't it? Our sun's death will provide the building blocks for future creation. And what about the white dwarf at the center? It will no longer be producing any new heat. It's just a stored ember, slowly radiating its leftover energy into space. For trillions of years, it will continue to shine, first a brilliant white, then yellow, then orange, and finally red, growing fainter and cooler over an almost unimaginable timescale. Eventually, after a period of time far longer than the current age of the universe, it will radiate away all its heat and become a cold, dark, inert ball of superdense matter known as a black dwarf, a dead star, invisible, drifting silently through the eternal night of the cosmos. The surviving outer planets, Jupiter, Saturn, Uranus, and Neptune, will continue to orbit this dark remnant, but their home will be a cold and dark one. The solar system, as we know it, a place of warmth and light, will be gone forever, replaced by a dark, frozen graveyard orbiting a stellar corpse. It's a dramatic and perhaps somber end, but it's also a natural part of the cosmic life cycle. Stars are born, they live, and they die, and in their death, they seed the universe with the elements necessary for the next generation. The very atoms in your body, the carbon, the oxygen, were forged inside a star that lived and died long before our sun was even born. We are, quite literally, made of stardust. So, the next time you feel the sun's warmth on your face, take a moment. Appreciate this incredible star that gives us life. It won't be here forever, but its legacy, written in the elements it creates, will be scattered across the galaxy, ready to start a new story. The end of our sun isn't just an ending, it's a new beginning for something else, somewhere far away in space and time. Thank you so much for joining me on this journey to the end of our sun's life. If you found this as fascinating as I do, don't forget to hit that like button and subscribe for more cosmic adventures. Let me know in the comments what other mind-bending space topics you'd like to explore next. Thanks for watching.